So this is where I have input the other equation. So we're going to look at it graphically because remember we said that these two, they are equivalent. If we are to factor this, we will get this as the factors. And if we were to expand this, we will get this to be the area. So let's look at the diagram and see if they are the same. Right now, when you look here only, so right now it is color code. So this one, the factored form represents, that graph is drawn in red. And the one that represents the expanded form, it is in blue. Right now, I'm highlighted on the one that is in standard form. And if you can see, that's the parabola. It's not going to show you both of the colors at the same time because it's sitting on top of each other. But let's look. What if I was to go here? So then I tapped on this. So I'm top. So you realize that the graph now the graph turns red. So it's the same graph. See, if I tap the other one, it changed color because they are the same graph line on top of each other. They're exactly the same. So when you do it graphically, once you have done it correctly, you should have both of them having the very same graph. Okay? So now we're going to move into something that is in your assignment. So there are different forms that quadratic expression can come in. It is called the factored form that I have been talking about. So for example, this would be the factored form. And it also comes in the standard form that I talked about. Now, even though in this example that we did before, here we were doing the quadratic. All those forms, which is the factored form and the standard form, they exist for all polynomials. It doesn't, not only for the quadratic, all polynomials. Now, it says, although as the power gets higher, the algebra may get a little trickier. In standard form, polynomials are written so the terms are ordered with the highest powered term first, and then the lower powered terms. Some examples, and this is actually in your notes. So this is saying that in the standard form, the standard form for polynomial, it is always written where the highest power is written first. So it's from the highest to the lowest. So if you look, for example, this is a quadratic. This power here, this x have a power of 2. This have a power of 1. This have a power of 0. So 2, 1, 0. So it's go from big to small. Or it could be like this. For example, this power right here is 2. And then this power here is 0. It's still going from big to small. Cubic, you realize this is written where the highest power is 3. Then the next highest power is 2. Then this power right here, this x have a power of 1. And then this have a power of 0. And this, and another example. Same thing here. The highest power is 4. And then 3. Then 2. Then 1. Then 0. So standard form of polynomial, it is always written where the highest power, from the highest to the smallest power. All right. Let us come to this part because you will see something like this in your assignment. So it says multiply and simplify both the following expression using strategy of your choice. So just to recap, remember this is x plus 1 all square. So how else could you write this? This is saying that you're going to multiply this by itself 2 times. So you would have x plus 1 times x plus 1. So, and then from here, you can remove the bracket by distributing or whichever strategy you would like, and you do up here. But this is where I want to go. Remember now we're trying to see how we can use what is called Pascal triangle to actually simplify this without having to do that long multiplication. So there is this table on yours. I put the heading. So up here would be the factored form. This would be the standard form or the polynomial, and over here is Pascal triangle. Basically, Pascal triangle, Pascal is a person. So he's the name of the mathematician that discovered a connection between the coefficients of the terms in the polynomial and the number pattern. So let me explain this so that you understand what to do. So right here we see where we have x plus 1 raised to the power of 0. Why is this here equal to 1? Why? Remember I said in previous classes, any base, anything at all raised to the power of 0 will always be 1. So that's why this one is here, because this is raised to the power of 0. Anything at all raised to the power of 0 will always be 1. This right here where we have x plus 1 raised to the power of 1. So this is just saying we have this multiplied just by itself. So this is just going to remain the same. So this x plus 1 to the 1 power is just the same. So we write x plus 1. Right here where we have x plus 1 all square, x plus 1 cube. When you get your answer from up here, because I'm not going to tell you, because you're supposed to multiply here. When you get your answer up here, you're going to write it. So for the answer here, you're going to write it here. The answer you get for this one, you're going to write it here. Now, this part that says compare your answers to the numbers in the Pascal triangle below and describe the relationship you see. So this right here, remember we said that we could write x as the same thing as, we could write 1 as the same thing as 1 multiplied by x to the 0. Why would that work? Because x to the 0 is actually what? 1. And 1 times 1 is 1. So see, we still get back this 1. So it says that the Pascal look at the connection between the coefficients of the terms. So in this one, in this term right here, let's say I keep this x to the 0. What would be the coefficient? And the coefficient is that variable that is used to multiply the x value. So for example, if I have 2x, this is the x. Right here, the coefficient would be 2. If I have a times x, the a is used to multiply this. So the coefficient would be a. In this case, see where I have my x. So the coefficient of this x would be 1. So when you look right here, the coefficient would be 1. Right here, the coefficient, or what number is in front of the x or multiplying the x, there's an invisible 1 right there. So the coefficient of this x right here is 1. So there are 2 terms in here. There was 1 term here, so that is why we only have 1. We're only looking at the terms. So here also there's another term. This term right here is similar to this one. So the coefficient right here would be 1, because we could just put x to the 0. We could say that is what this is. So the coefficient of x to the 0 is 1. So that is why we have 1. When you complete these 2, you're going to look to see look at the connection between these numbers here and the coefficient here, and then you're going to answer the question. No, but let's talk about Pascal triangle now, because you're gonna have to actually complete or draw your own Pascal triangle. So let me help you here. So you see, when we started out, the lowest power we can go for it to be a polynomial is 0, because remember, we cannot have a negative exponent. If we have a negative exponent, it is not a polynomial. So the lowest we can go is 0. All right. So see, we have 1, and then in this one where it is 1, we have 1, 1, then we have 1, 2, 1, and then right here I have 1, 3, 3, 1. How do you think we get from here to here? Any idea? Okay. So when I'm looking at it, I'm realizing that we have 1 at the start, 1 at the end. So if we were to start here, how can we get here? So we know we're going to have a 1 here and a 1 here. So if we look, 1 plus 1 gives us 2. Good? So it's like over here, there's like a 0. So 0 plus 1 is 1. 2 plus 2, sorry, 1 plus 1 is 2. 1 plus 0 is 1. When we go here, 1 plus 0 is 1. 2 plus 1, we see 3. 2 plus 1 or 1 plus 2 is 3. And then we see where 1 plus 0 would be 1. What do you think will come here? Figure that out. What would come here? So we know we are seeing some 1. What would come here? So that is basically how you're supposed to look at the table and then just read the instruction and complete it. I have started it somewhat and just explain what is expected of you. I hope this helped you to do what you're supposed to do.